All right, so this video covers the last three examples for section 2.5, and I'm going to use implicit differentiation for each one of these three. So number 17 gives you cosecant x is equal to x times 1 plus tangent of y. All right, so when I worked this problem out, I went ahead and distributed the x on the right side, so I had cosecant x equal to x plus x tangent y. And now I worry about differentiating. So recall the first thing I need to do is to take the derivative of both sides with respect to x. So it'd be d dx cosecant x and then d dx of x plus x tangent y. All right, so the derivative of cosecant is negative cosecant cotangent from the different trig derivatives we already learned. So this would be negative cosecant cotangent. And you can reference the derivative table that I have up on Blackboard in case you didn't remember that, but that's what its derivative is. So then I apply the derivative operator to both terms in the brackets. And derivative of x is 1. So it'll be 1 plus, and then I'll talk about how we find the derivative of x times tangent y. All right, so I have x times tangent. This is a product, so I have to use the product rule for the derivative. All right, and in this case, I'm letting u be x, and then v be tangent of y. So derivative of u prime, that's going to be derivative of x. Derivative of x is 1, so u prime is equal to 1. And then the derivative, the derivative for v, so v is tangent. The derivative of tangent is secant squared. So b prime is secant squared of y, but since I'm dealing with the variable y, I have to attach a y prime to that. So it'd be secant squared y prime, again, because I'm taking the derivative, in this case, of variable y, with respect to x. So if I take derivative of x tangent y, based on product rule, we u prime times v. U prime is 1, so it'll be 1 times v, which is v is tangent of y, and then plus u is x, and then times v prime. And that's secant squared y prime. All right, so you could just write it as tangent y plus, I'm going to put the y prime next to x. It's just reference thing. and just put as x, y prime, secant squared y. Just because, I don't know, just looks visually more appealing. Now this is just what all of this part is. All right, so to combine everything together, I have negative cosecant cotangent equals to 1, then plus, and then I'll put in purple the derivative of x tangent y. That was what I circled over here. All right, and that's what we get. And remember the goal here, now we've taken the derivative. Now the goal is to get y prime by itself. All right, so to achieve that goal, the only term that has y prime is the xy prime secant squared of y. So I'm going to get that by itself. And the first thing I need to do is get rid of the 1 in the tangent y. All right, and I know in the guideline for this, you usually want the y prime by itself on the left side, but in this case, we already have y prime on the right side, so I'm going to keep it over there. All right, so negative 1 minus tangent y minus cosecant x cotangent x. All of that's equal to x, y prime secant squared of y. So for the right side, I'm just going to factor out y prime. And then that's going to give me x secant squared of y. And then the left side is still the same. All right, to get the y prime by itself, I'm going to divide both sides by x secant squared of y. All right, so we will have y prime. I know it's on the right side, but I'm going to go ahead and just write it on the left side. It's equal to negative 1 minus tangent y minus cosecant cotangent over x secant squared of y. No, that's pretty much it. That's the answer for that. And you could factor out a negative 1 if you want, since all three terms from the top have a negative. And it's just going to be the same thing. It's, if you want to write it like this, you can just negative 1, then parentheses 1 plus tangent y plus cosecant x cotangent x over x secant squared y. So whichever of these two you want. All right, so that's how you do that one. The next one is number 37, and we're going to find the equation of a tangent line. right, and we're going to use implicit differentiation. So the function, or the equation is y minus 3 squared equal to 4 times x minus 5. And the point where we're finding the tangent line is going to be 6, 1. So recall for the tangent line, the first thing we need to do is find the derivative. Then we use the derivative to find the slope. So find slope m by plugging in the coordinates of the point into the derivative. This time, for this section, since our derivatives, we're doing implicit differentiation, and the derivatives involve both x and y. When we find the tangent line, finding its slope, we have to plug in both coordinates, x and y, into the derivative. Whereas before, we just plugged in the x coordinate. All right, then after we find the slope, we just form the equation of the tangent line. And I use point slope form. And that's the process. Find derivative, find the slope by plugging in the coordinates into the derivative, and then form the equation. All right, so our equation is y minus 3 squared equal to 4 times x minus 5. I'm going to go ahead and distribute the 4, so it'll be y minus 3 squared, and then it's equal to 4 times x, and then 4 times minus 5, so it'll be 4x minus 20. Now you could expand the y minus 3 squared. I'm just going to apply chain rule, and now I just take the derivative. I'm going to use implicit differentiation. And so I do the derivative with respect to x to both sides. That's the first thing. All right, so taking derivative of y minus 3 squared, it's basically using the general power rule. And the general power rule when applying the chain rule. So it's d dx u to the n is equal to n times u to the n minus 1 times u prime. In this case, u is the y minus 3. Derivative of y minus 3 is just 1. So u prime is 1, but since I have the variable y, I need to attach a y prime to it, because I took a derivative with respect to x of the variable y. And so every time we do this, we always attach this y prime. So in this case, the y minus 3 squared, you drop down the exponent, so it'd be 2 times y minus 3 to the 2 minus 1, that's this portion, then times u prime. Well, u prime is 1 times y prime, which is just y prime. All right, and then all of that's equal to the derivative of the right side. And you apply the operator to both terms, and the derivative of 4x, the derivative of x is 1, so derivative of 4x would be 4 times 1, which is 4. And then derivative of 20, that's a constant, so that the derivative of a constant is 0. So really it'd be 4 plus 0, which will be just 4. right, so now I have the derivative. And I just get y prime by itself by dividing both sides by 2 times y minus 3. All right, so the derivative y prime is, so u4 divided by 2 is 2, so it would be 2 over y minus 3. All right, so that is the derivative. Now I'm going to find the slope. Our point that we're given in the question is 6, 1. Notice the derivative itself only has the variable y. So we would normally plug in both x and y, but since the derivative only has the variable y, we're only going to plug in the y coordinate of the point. And so the slope is going to equal, and plugging in 1 in for y, that's going to be 2 over 1 minus 3. If it had a variable x involved, we would plug 6 in also, but in this case it doesn't. So that's 1 minus 3 is negative 2, so it's 2 divided by negative 2, which is negative 1. That means our slope is negative 1. So now I'm ready to just go ahead and find the equation of the tangent line. And I use point slope form. So m is negative 1. I have the point 6, 1. That's what I use for x1, y1. All right, that's the point which we're interested in. So it would be y minus 1 equal to negative 1 times x minus 6. All right, and that's the equation for the tangent line. So that's going to be our answer. Or if you wanted to put it in slope intercept form, that will become y equals negative x plus 7. Right, this is slope intercept form. So whichever one you want to go with. All right, so this is the last problem, and it's the same kind of example of finding the equation for the tangent line. And we have x squared y squared minus 9x squared minus 4y squared equal to 0. So again, first thing we got to do is find the derivative. After we find the derivative, then we find the slope. And the slope involves plugging in the point, the coordinates of the point, into the derivative. And after we have the slope, we can form the equation for the tangent line. So I'm going to first, so we know we take the derivative with respect to both sides. So I'm going to first focus on, if I were to take the derivative of x squared, y squared. And again, I'm going to be using the product rule because I have a product. In this case, our u is x squared and the v is y squared. By power rule, derivative of x squared, that becomes 2x. So u prime is 2x. V is y squared. So, and similar power rules being applied, so it'll be 2 times y. But then since it involves y, we attach the y prime. So derivative of x squared y squared based on power, or sorry, not based on the product rule, u prime times v. Well, u prime is 2x. V is y squared, so it's 2x y squared, plus u times v prime, so u is x squared, and v prime is 2y y prime. All right, and maybe just reorder it so it looks like the following. So do 2x squared y prime. That's usually the particular order that we're used to. And all of this is just the derivative of the x squared y squared piece. All right, so I went ahead and just found that. All right, so the problem, take the derivative with respect to x to both sides. The right side's just a constant, so that's derivative is 0. If I distribute the operator to each term, and then the minus 9x squared, I'm going to go ahead and factor out the minus 9, and then write it as d dx x squared. And then similar thing for the 4y squared, I'll factor out the minus 4, and then d dx of y squared. And then we already found the first piece. That was what I had in green. That's 2x y squared, 2x squared y prime. All right, so that's the first piece. Now for the negative 9 and then derivative of x squared. Well, derivative of x squared is 2x, so this would be not minus 9 times 2x. And then for the last piece, it's going to be minus 4. And similar thing, it's going to be times 2y. But this has the variable y, so I'm going to be attaching a y prime. And then equals 0. So I'll have 2x y squared plus 2x squared y prime, negative 18x, and then minus 8y prime equal to 0. So if we're going to get, again, the goal is to get y prime by itself to get its derivative. Well, the terms that have y prime is this one and that one. So I'm going to write those down. Now the other two terms do not have y prime. And so for the other two terms, you would bring them over to the right side. For the 2xy squared, I would subtract 2xy squared from both sides in order to get rid of it. So it's going to be equal to negative 2xy squared. And then the negative 18x, you would add 18x to both sides. So I would plus 18x. We're almost there. I just got to factor out a y prime. That makes this 2x squared y minus 8y. And then equal to negative 2xy squared 18x. And divide both sides by the 2x squared y minus 8y. right, so let's see if we can do some simplifying. So y prime equals, all right, so the top part, negative 2xy squared plus 18x, I could factor out either negative 2x or positive 2x, whichever one I want to go with. I might just try just factoring out 2x, and that makes this negative y squared and then plus 9. And for the other stuff, I can factor out a y, but I can also factor out 2. So I'm going to factor out 2y. That makes this x squared minus 4. And I could divide out the 2's. All right, so the negative y squared plus 9, that is the same thing as 9 minus y squared. The x squared minus 4, you could factor this, and sorry, I still have the x and y, so I need to put that. And the x squared minus 4 is the difference of squares, so that factors into x minus 2 times x plus 2. 9 minus y squared is also a difference of squares. So it'll factor into 3 minus y times 3 plus y. All right, and that is the factored format for that. So y prime and now I can find the slope. So this is the derivative. Now find its slope for the tangent line. And we do that by plugging in the coordinates of the point into the derivative. So the point is negative 4 comma 2 square root of 3. So we plug negative 4 in for x and 2 square root of 3 in for y. So in this case, we have both variables. We do plug in both coordinates. So y prime, so x is negative 4, then times 3 minus y. That's going to be 3 minus 2 square root of 3. Then 3 plus 2 square root of 3. And on the bottom, we have y, which is 2 square root of 3, times x minus 2, x plus 2. Well, x is negative 4, so this is negative 4 minus 2, times negative 4 plus 2. And now we just got to simplify this beast. All right, let's see, what can we do? Well, I could divide negative 4 by 2, so that makes that negative 2. Negative 4 minus 2, that's negative 6. Negative 4 plus 2, let's see, so that's going to be negative 2. So that's negative 6 times negative 2, which is 12. So on the bottom, I have 12 square root of 3. Again, I just did negative 4 minus 2, that's negative 6. Negative 4 plus 2, that's going to be negative 2. Negative 6 times negative 2 is positive 12. And I still have the square root of 3. So it's 12 square root of 3. And I have negative 2. And then times 3 minus 2 square root of 3. And then 3 plus 2 square root of 3. And then I would FOIL the top part. So maybe all that factoring was a little excessive, but I went ahead and did it. So I'm just going to FOIL this. Now notice I have a minus and a plus. That's the difference of squares part, and our difference of squares, a minus b times a plus b is equal to a squared minus b squared. And so like our a is 3, our b is 2 squared of 3. All right, so this will equal -2, and then I'll put everything in parentheses, a squared minus b squared. So that's going to be 3 squared minus b squared, and b is 2 squared of 3. And then I still have 12 squared of 3 on the denominator. All right, so I'm still trying to simplify this as much as I can. So it's going to be -2 times 3 squared is 9, so we have 9. And then when you do 2 squared of 3 squared, 2 squared is 4, so it'd be -4. And then square root of 3 squared, you get rid of the square root. So it'd be -4 times just 3. And I just, square root of 3 squared is 3. That's where that comes from. 2 squared is 4. All right, so I basically have 9 minus 12. And that's going to be, so what is that? So this is 9 minus 12, and that should be, just blanking out here real quick. That's going to be -3, right? So I have -3, because that's 9 minus 12 is -3. And then over 12, square root of 3, and then I do -2 times -3 is 6. That's 6 over 12 square root of 3. And you can reduce this. So this reduces. And so the slope will be, and you divide top and bottom by 6, and you'll get 1 over, and then 2 square root of 3. All right, that's what I get for that. And I'm going to double check the algebra to make sure there's no mistakes here. That's usually where things get tripped up. Okay, so this problem, again, we took the derivative of both sides. The x squared y squared piece, that was what I tried to do first. And that was using the product rule, where u is x squared and y, and b is y squared. And so our u prime b is 2x times y squared plus u times b prime. That's going to be x squared times 2y y prime. And I just put it as 2x squared y prime. All right, so that's what the green stuff is. And it's all was written down correctly. And then for the x squared, that's -9 times 2x. And then for the y squared, the derivative of that's -2y, so it'll be -4 times 2y, then y prime. All right, then I wanted to get y prime by itself. So the only terms that had y prime are 2x squared y prime, and then -8y, y prime. So I just left those in the left side. I brought over the 2xy squared and the -18x to the right side, so they would have opposite signs when you do that. All right, and so that looks all good. Then I factored out y prime, and I divided by the 2x squared y minus 8y. And then I try to do some factoring just to see if that would help any. And I might have gone a little too far with it because it ended up where it plugged in the values, it might have made it more difficult. And so the top part, just to check, so I factor out a 2x, and that would make that -y squared plus 9. And that's the same thing as 9 minus y squared. So I just went ahead and wrote that as 3 minus y times 3 plus y. And then I obviously divided by the 2's. When I factor out 2y, that would give me x squared minus 4, which is x minus 2x plus 2. So all of that seems checks out to be correct. And so the derivative was this, x times 3 minus y, 3 plus y, and then y times x minus 2, x plus 2. So that's correct. And now I just got to check to see when I plug the coordinates in if that ended up being correct. All right, and just double checking, when I plugged everything in, it does look all correct, and that I would get 1 over 2 square root of 3. All right, you can rationalize this, even though this is fine to have it, but if you were to rationalize, I would multiply top and bottom by square root of 3. So that way the square root's no longer in the denominator. So you have square root of 3 up top. Square root of 3 times square root of 3 is 3. So this is 2 times 3. So it would be square root of 3 over 6. All right, all of that to get the slope. All right, now we are finally pretty much done. We just got to form the tangent line. So the calculus part's not what's difficult, in my opinion. It's all the algebra steps. So the point that we were given was -4 and then 2 square root of 3. And I plug it into y minus y1 equals m times x minus x1. So I'm just plugging those coordinates in. This will be y minus 2 square root of 3 equal to, and our slope is square root of 3 over 6, so square root of 3 over 6 times x minus, well, it's -4, so it'll be turned into x plus 4. All right, finally, that is the answer. And then slope-intercept form, if you were to put it in slope-intercept form, it would be the following: y equals square root of 3 over 6 x, and then plus 8 square root of 3 over 3. So, or if you wanted it like this, you could put it like that, in slope-intercept form. All right, so that is it for this section. I think I will put one more video going over a complicated problem, and it might be a similar problem on the test for extra credit. So that's what I'm thinking of doing. So keep tabs on the videos. The next video will be going over a difficult problem, and on the test I might ask a similar problem but for extra credit.